Hello everyone, welcome to my channel. Today, finally, we are going to start module 2 where we will be discussing about human organ systems and biodesigns. So, in module 2 and module 3, it is a continuation topics like human organ systems we take. For example, we take a brain and we will study what is brain and by inspiring the brain what we are having, like for example, computer, CPU of the computer which exactly works as a brain but not completely. Similarly, we are having heart as a pump machine, kidney as a filtration system, like that. Okay, so we even in the design 2 also we are having different these things, what you say, the organs. We are taking some particular organs, okay, and we are discussing on them and their engineering applications, and related to that what engineering has to contribute to these particular diseases related like Alzheimer disease or Parkinson diseases, all other stuffs we are going to discuss. So in module 2 we will start now. So before that I will just give you a simple note. So module 3, module 2 and module 3 we are discussing now. So far we have completed module 1, module 4, module 5. So module 2 and module 3 I have kept it for later stage. Now you can find my videos for module 1, module 4 and module 5 as VTU syllabus. Okay. You can also, there are a lot of universities in the India, they are also following this subject and with little bit changes in their this thing, but the topics are all covered here. So soon I will be sharing. If you have any doubts in this particular my videos, you can get back to my email ID. Every description it will be there. Recently I will be soon I will be sharing my phone number and WhatsApp link and link this particular Telegram link also, so that we will share you with you guys, so that we can have a community there. You can discuss if you have any issues or any doubts are there, we can clarify there. So let's start module 2 today. So that is human organ systems and biodesigns 1. So biodesigns 2 will be module 3. So module 1, the first topic is we are having brain as CPU system. So let's give an introduction. So basically, whatever we are having, whatever we are, even including what I'm explaining now and what you are listening, what you guys are listening, and what you are doing the tasks every day, every task, whatever it is being performed by us is computed by the brain. Agree? So we'll have to agree because brain is the our major CPU. If we imagine we are a computer, our CPU is brain. Okay. Similarly, for a computer, brain is CPU. Understanding? So that means the number of processing different tasks per second. Okay. So it will be more in brain compared to the CPU in the computer. Okay. Imagine there are thousands of cycles, biochemical cells which are going inside our body. I am looking, okay, that means my vision is working. Okay, I'm talking at the same time I'm talking, that means my mouth is working and lot of cells and tissues are working here when I'm talking, and when I'm signing, okay, my hands are moving. Okay, and when you guys are listening, your ears are hearing the stuff and you are responding to it, you are understanding what I'm explaining, or you are having any doubts, or everything is connected to the brain. Everything is connected to brain. Every single task we do is connected to brain. That means brain is having capability of doing so many tasks, multitask at single second. Okay, so it millions to billions of tasks per second brain is able to do. Okay, whereas CPU as in other hand does the same work, okay, but it cannot be compared to the brain at all. But as of your syllabus, so or as of your as a topic of an argument, we, yes, for a computer CPU acts as a brain. Whatever brain is performing task for our human body, CPU does that for your this thing. For in that view we are comparing these two things, whereas CPU cannot forget about 100%, not even go 50%, can achieve 50% of brain's efficiency. Okay, so far there is a lot of studies and most of the scientists have made comments like, so far whatever the so far technology we got, okay, from aircraft to the rocket technology, landing on the moon to the planning to go to the Mars, okay, all these things, whatever the brain brainstorming, or the ideology is involved, all idea generation is involved. All these things, if we combine together, okay, we can say that scientists say that there is only 10 to 15% of brain's efficiency has been used so far. Now imagine what can happen if you use 100% of brain efficiency. Obviously there are fictions movies which has been made. For example, Lucy is one of the Hollywood movie where they show that what can happen if human can explore his brain 100% its efficiency. So that is just a what do you say, one of the idea, or whatever this thing is there. They have just portrayed it. It can be like this, but always remember that today's fiction can be tomorrow's reality. So that's what we are going to explain. That's why we are going to explain brain as a CPU system. So brain works as a CPU system. Okay, so let's begin with the topic. Those are all introduction behind that. Those are very important for your knowledge point of view. You can also get those knowledges, okay, by going through the lot of daily newspapers, or many articles which have been published in scientific data and all. Okay, there are a lot of stuff, pretty much stuff is going on this brain as research and other stuff. Now let's start the topic. The human brain can be thought of as highly sophisticated and complex information processing system which is similar to the CPU. That means obviously it is highly sophisticated and complex information processing system similar to the CPU, right? Nowadays we are having supercomputers, quantum computers. Okay, the China has come up with the supercomputers. Okay, the US has come up with the supercomputers, the Russia, okay, all these top countries, including European like UK, okay, those all countries are coming up with the supercomputers, and some of them they have even come up with the quantum computers. So quantum computers, what is the difference between the quantum computers and the normal computers? The normal quantum computers, what we are using, it works on two things: Boolean algebra and laws of physics, whereas the supercomputers works on Boolean algebra, which is common again, but laws of quantum mechanics. So there is a difference between laws of classical physics, laws of advanced physics, or laws of quantum mechanics. Advanced physics can simply be called as quantum physics. So quantum computers works on the advanced physics, whereas normal computers works on the basic physics or classical physics. Now what is the difference between classical physics and quantum physics? Classical physics deals with the normal whatever we have studied so far, whereas quantum mechanics deals with whenever we are going at the atomic level or molecular level, or the huge comets, or huge whatever huge bodies. Okay, the lot of the science involved inside this particular at atomic level changes, at nucleus level changes. Okay, it is not as same as the bulk. For example, in classical physics we had thought that electron has got only one property, that is particle nature, whereas in quantum mechanics teaches us electron cannot have only one property, but it is actually speaking it is having two properties. That is nothing but particle nature, which is 50% of the whatever this has explained, but another 50% electron can also behave as a wave, that means wave nature. So that's when the quantum mechanics, that's where the quantum mechanics differs from classical mechanics. There are a lot of things are there to be analyzed or to as a matter of argument, but this is the major one of the major point where the quantum mechanics and classical physics has got a different opinion. That means you might be thinking, now then what is the physics, whether what we studied is wrong. No, it is not like that. So till 19th century, whatever the discoveries were made, if they were depending on only particle nature, there's all theories still holds good. Okay, if the quantum mechanics after coming, once quantum mechanics developed, and when the physics itself, advanced physics, they say they found out that electron has got the dual nature, that is wave nature also. If all the discoveries which is made earlier 19th century or before the 19th century, if those discoveries were dependent on wave nature also, okay, then that theory is going to fail. Why? Because whatever you think the electron is having the particle nature and you made the theory, but that particular theory is also depending on the wave nature, then you are going to be wrong. If it is depending on only one particle, one nature, that is particle nature, then you are going to be right. Understanding? So that's how the things works here. So quantum mechanics and quantum bits. Here also in classical physics, it works on bits, 0, 1. We know that. Whereas in quantum mechanics, quantum computation, it works on qubits. Okay, here 0 and 1, only 2 states. Whereas in qubits, there will be 4 states, 0, 0, 0, 1, 1, 0, 1, 1. So 4 states, here it is 0, 2 states. So here 2 states, as a computer scientist, the scientists say that in 2 states, we can able to explain if there is a globe, we can able to explain only South Pole and North Pole, 0 and 1 in classical computation. That means we can have output very limited. Whereas in quantum computation, we can have whole sphere. Like we can cut the sphere like this, 0, 0, 0, 1, 1, 0, 1, 1. So that the whole sphere will act as one whole information system. Now this is also information system. If this is if the both the information system is there, the quantum mechanics will explain the complete information system, whereas this particular classical mechanics or classical computation what we are having explains only South Pole and North Pole. Understanding the difference? If the globe is the information system, the quantum computation can explain it completely, whereas classical computation what we are using now can explain only South Pole and North Pole. That is the big difference actually, and that's how qubits are going to make it, and that's how the quantum computation will bring a new area of invention where a lot of research is going on so far, so that the computation speed will be almost 10 to 100x faster than whatever the right now computers we are having, or even it is believed that it will be more than 10 to 25x faster than the supercomputers whatever you have achieved so far. So there is a difference between classical computation and quantum computation. I hope you understood so far. So even the why I have explained all these things, because even the quantum computation also cannot compete the processing speed of brain. Understanding? So that's what the point I wanted to make here. So let's begin. So human brain is a very highly sophisticated and complex information system which is similar to the CPU, or you can just say that CPU is similar to brain. So both the brain and CPU receives and processes inputs, store the information, perform the calculation to produce the outputs. For example, imagine a dog is chasing you. Okay, suddenly the brain receives the signal that dog is coming, is chasing you. So dog is coming near to you. So that signal is received by your eyes will see this, and the signal is transmitted from eyes to the brain. So brain will start thinking, it will start processing, and when it starts processing, okay, it is the input what the eye has given the input. Now it will process the input. It receives the information. It starts processing the inputs, that is whatever the received by the eye. Now it will store the information. It stores that, okay, brain, the dog is chasing me, and then it will perform the calculation. That means it will perform the calculations in the sense you will start running. You will start running. Why? Because brain has instructed you to run. Because that brain will, that with the movement itself, the brain will send a signal to the legs, and legs will start running. Understanding? So see, within a fraction of seconds, the brain is performing all these tasks. It is getting the information, it is receiving the input, it is processing the input, it is storing the information, it is performing the calculations, how to run, what area we have to choose, and what direction we have to choose. So these all things comes under calculation. And then how fast I should run. Okay, can I keep running, or shall I take another shelter, or can I jump off the particular, the compound? All these things are the calculations which is performing by the brain. Isn't it amazing? So this simple, you are just escaping from the dog, but here the brain is performing the magnificent work. Because of brain only you are able to do all these things. So that's how these things work. So even the CPU also does the same thing. That was about brain. CPU also does the same thing. You give the input, it receives it, it processes the inputs, it stores the information, it performs the calculation, then it will produce the output. Finally you get the output, go home. Understood? So that's how the brain and CPU works together. So however, there are significant differences between the two things, both brain and CPU, such as, for example, the way they store and process the information. How they are storing the information, how they are processing the information, it is totally different. Okay, and the fact that the human brain has ability to learn, adapt, and while computers CPU does not. So CPU can only take the input, receive the input, store the input, process the input, and give the output, whereas the brain, okay, at the same time brain does the same thing, but brain will give extra work also. It brain has got ability to learn new things, it will adapt to the new things, and then but CPU does not adapt. CPU is what you give by, I will do that work and then I'm off. But brain is not like that. It is keep on adapting. If you are learning, for example, if you start learning particular game, you will start with a very bad game, and then you will daily, if you are consistent with your game, and you will start improvising, right? Why? That is why you are improvising, because your brain is able to do the task better day by day, whereas CPU cannot do the task day by day better. Now today is poor output, tomorrow is better output, the day after tomorrow is the best output. No, CPU cannot do like that. It is like whatever you have given today, the same output is tomorrow, same output is day after tomorrow. But brain is not like that. It has got ability to learn day by day, and it will adapt to the changes, while CPU computers cannot. That's why we are here. So before a century back, we didn't have flights. Okay, not everyone was accessed with the with the train. Okay, we didn't have computers, we didn't have cell phones. Just 25-30 years back, we didn't have cell phones. But see how our brain adapts learning this process, and it will adapt. Even our parents are using cell phones, smartphones nowadays. Okay, so that's how the brain works. I mean, even though it has got ability to learn and adapt very rapidly, whereas CPU does not. Okay, so additionally, the human brain is capable of performing tasks such as perception. Okay, the human brain also thinks about different perceptions, okay, different views, okay, thoughts will change. For example, I am having one thought based on one subject. Now I want to drink a tea. Now I'm planning, okay, should I drink tea or not? No, let's take a coffee. No, coffee is also not good. I don't want to take coffee. I will take a juice. Which juice? Again I will start thinking, okay, lemon juice or apple juice. No, I have got a little bit cold. I'll not go with the lemon juice. I will go with some other juice. I'll go with the mango juice. Understanding? So these all things, okay, all coming under the perception, thoughts, then emotions. We are having emotions because of, again, the brain. Brain can control our emotions, and it can also have the control over whatever the emotions we are having, are surrounded by our people, surrounded by the people, right? So which are beyond the scope of the computer CPU. But CPU cannot do all these functions. It doesn't have ability to learn. It cannot adapt to the changes. It cannot have any perception and thoughts or emotions, because these are the things which are naturally coming to the brain, whereas the computer, you need to give the input first. Okay, without input it will not take it, other than input takes everything as error. So basics of comparison, or you can say the basis of comparison for a brain and a computer. The first thing, construction. So how his brain is constructed? It has got neurons and synapses. So that's where the communication skills are going on. So next, so there are billions of neurons are there. Every neurons has got its own task. So billions of work tasks can be done by the brain within a second. Next, CPU or a computer. So computer here, it has got, what is the structure construction of the computer? It is made up of ICs, that is inter circuits. Next we are having the transistors, okay, where source, drain, and base will be there. Okay, the electron will jump from the source to the drain. Okay, all those things will be there, right? So there's a conduction will happen based on that. Why? Because the more number of the transistors, more number of the tasks. Next, diodes, capacitors, transistors, these all things are present in the computer's construction. Whereas next basis is memory growth. So memory growth we are having in the brain, it increases each time by connecting synaptic links. Whenever there is a synaptic link, it will remember. For example, you meet a new person. They are just going by a train, and the next to the you as one person is sitting. Okay, you are talking to him, you are talking, and then you will have a bond with him. You start your characters match, your thoughts match. You will start speaking to him, so that you can have a very good interaction with him for hours. Okay, so you will remember him. Okay, that particular brain will remember his face. Okay, even after 1 week or some other day or days after months later, if he is coming in the same train, if you again you happen to meet him, you will remember him. Understanding? So that is the memory growth of brain. So it increases each time by connecting synaptic links. You see, this is happening because of the synaptic link. Once you get the synaptic links, your brain is able to remember. Next, increased by adding more memory chips. Okay, that is in CPU. So you know that Moore's law, every 16 18 months the number of the uh, chips sitting in a particular area will be, transistor sitting in a particular area will be doubled. So that means every 18 months we can double the activity of the computer. That means the tasks can be doubled. Understanding? So the you have to add, in order to get the more memory, you need to add more memory chips. Next, backup systems. So here in brain, it built in backup system. Built-in backup system is nothing but it has got something called conscious and subconscious memories. They remember the things. They will act as a backup system. For example, suddenly you will try to recall some song. You know the, what you say, the rhythm, but you don't know the song. Okay, but after some time, if you recalling for a few seconds, okay, suddenly you will remember that song. That is because it is stored in subconscious memory. Even after 10 years, that song will come to you because it was stored in your subconscious memory. That is called built-in backup system. Whereas here computer backup system is constructed manually. So here backup system will be based on the whatever you want it to be. Next, memory power. So here memory power is 100 teraflops. That is nothing but 100 trillion calculations per second. Okay, imagine 100 trillion calculations per second, and see where CPU stands. It's just 100 million megabytes. Forget about the these things. What you say, billion, not even in forget about trillion, not even in billions. Okay, so imagine, so there is almost there is a huge difference. Okay, you can't even imagine, there is so much difference is there. You can say the billion times, you can say almost 100 billion times better, faster. Brain is faster than the computer. Next, memory density. Here it has got memory density, that is 10 to the power 7 circuits per cm square. That means if you are keeping the circuits in that particular area, 10 to the power 7 circuits per centimeter square, here it will be 10 to the power 14 bits. Here it is circuits, here it is bits per centimeter square. Whereas here energy consumption is 12 watts of power, here it is gigawatts of power. So okay, so these all are approximately calculated with some scientific evidence. Next, information storage. Here it is stored in electrochemical and electrical impulses, whereas here it is stored in numeric and symbolic form. Here it should be in the 0 and 1. Okay, whereas here it what happens in electrochemical and electric pulse impulses. Say electric impulses we need that, so that the brain will get the signals, and again the signal brain will get that signal and it will transfer it back to it. So it is electrical pulses and electrochemical also. There will be some chemicals which are changed in the body. Then just because of this chemical is changed, the brain is reacting. So electrochemical and electric pulse. Next, size and weight. So the brain's volume is around 1500 centimeter square cube, and weight is around 3.3 pounds. Whereas here computers, its variable weight and size from few grams to the tons. Okay, it depends on whether you are using normal computer to the supercomputers. Next, transmission of information. So based on this, we are having, it uses the chemicals to fire the action potential in the neurons. To get the action potential, the neurons to do the work, brain will have the chemical activity. Based on that only it will start functioning. Next, here the communication is achieved through the electrical coded signals. So here the communication will be achieved based on the signals. Next, information processing power. So here it is low, information processing power is low, where here it is high. But even though if it is high, it can go for a long. Okay, next, input output equipment, sensory organs. Here lot of sensory organs are there, like vision, as I told you. If anything touches, we will just move away. All these things are like based on the sensory organs. Next, here it will be keyboard, mouse, web cameras, all these things that is input output equipment. Next, structural organization. Here brain is self organized, whereas computer is pre-programmed structure. Okay, that means it is pre-programmed already. Everything we know already about computer. Whereas next, the basis of a comparison is a parallelism. Parallelism is very massive here, whereas here it is computer is limited. That means ability to perform a parallel works or multiple works at a single time. Say I'm talking, I'm getting the my hands moving to in order to understand you by with the different signs. Okay, and also I'm thinking, I'm listening, I'm seeing, and sorry, I'm seeing, I'm explaining, and you guys are listening, and along with that you are doing some other tasks also, right? So this is a parallelism. It's very massive in brain, whereas it's limited to the computer. And reliability and damageability properties. In that, brain is self-organized, self-maintaining, and reliable. Okay, whereas computers perform a monotonous job and can't correct itself. Okay. So brain's architecture we will discuss in the next class.